Hey class, welcome to chapter 23, linear programming. Today we will be looking at exercise 23A, regions defined by an inequality. So when we plot an inequality, it's just like plotting any other linear relation. The only difference is that we're using symbols less than, greater than, less than or equal to, or greater than or equal to, instead of just equals. Okay, so these kind of take the place of your equal sign. Okay, we're going to try two examples in this video. The first is going to be plotting an inequality which includes the boundary. Okay, and in this particular case, the boundary line is x equals 7, or x is less than or equal to 7. Okay, so our first step is to just plot the graph of x equals 7. So if I have my x and y axes, it doesn't have to be very well drawn, okay, and I have 7 there, my graph for that would typically look like this. Should go through the 7. Sorry, I'm drawing on a graphics tablet. Okay, I plot the graph of x equals 7, in this case with a solid line, and the note here in the bottom right hand corner states that solid lines indicate either less than or equal to, or greater than or equal to. In these cases, the boundary is included in the required region, and that's that little or equal to part of that inequality. Okay, and then we need to shade and label the region. So here I've got x equals 7. Okay, and I want to shade the half of the line that's required. This is a nice and easy one. We're talking about any value less than 7 in the x-axis is required. So I'm either going to colour in the lower half or the upper half of the equation. In this case, we're looking at the less than side. So this is the required region. In some cases, we can shade the non-required region and leave the blank region empty. However, when you plot things on your CAS, it will actually shade the region that you've coloured in. So just to be sure, what we'll do is we'll shade the required region and we will label it. So I like to write the words required region quite literally on there. Okay, and that's it. That's how we plot an inequality which includes the boundary line. It doesn't have to be anything prettily sketched, okay, or pretty coloured in. You could use a highlighter like I have as well. Our second example, we're plotting an inequality that does not include the boundary. So in this case, we've got just the less than or greater than symbol. We'll notice that the difference between this equation was that we had the or equals to, and here we do not. Okay, so similar steps to the last equation, but we've got a bit more of a complex sort of inequality here. Our steps are pretty much the same though. So we're going to plot the graph of 3x take 2y, this time with a dashed line, and we'll come back to that in a moment. So first of all, to plot that line, 3x take 2y equals 8, and that's what we're going to plot. Okay, we need 2 points on the line. This is written in our intercept form, so I'm going to solve for the x and y intercepts. So if x equals 0, I get negative 2, y equals 8, giving me y equals negative 4, and there's 1 point. There's my y-intercept. And if I let y equal 0, I get 3x equals 8, which gives me x equals 8/3, or I could rewrite that if I wanted to as 2 2/3, if that helps your brain. Okay, so now we need to plot the graph. So I need my graph to go, sorry, very poorly drawn, but that's okay. So my x and y axes, okay, I've got 1, 2, 3, y is negative 4 there, and I've got 1, 2. I've just drawn the number 2 twice. Amazing. And we're looking at drawing our line through those 2 points that we just found. The y-intercept was negative 4, and the x-intercept is 2 2/3. And I just realized I haven't actually drawn that wide enough. That's okay, we fix. All right. That's better. Okay. So we now need to plot the point. If we break that into thirds, we're looking at about there. Okay, so there's our two intercepts. we're going to draw a line straight through, except that we need to plot the graph with a dashed line, okay? So because this particular equation does not include the boundary line, we use a broken line to indicate that it's not actually included in the graph, okay? So instead of the solid line, we need to replace it with a dashed line, like so. If you're doing this in pencil, you can quite easily go through and just erase small portions of the graph as well. Okay, our last step is to shade the required region and to label it. Before we do this, we need to figure out a point to test. So I'm just going to label the line really quickly. Okay. So we pick a point to test. My recommendation is to always test the origin, 0, 0. I always find it's the easiest point to substitute in. Okay, if however your line passes through the origin, so that way or that way, you would need to pick another point, in which case go this one. Okay, 1, 0 or 0, 1. Anyway, we're going to test the point 0, 0. So I write test. I'm going to write the coordinate as well. If x equals 0, then I get 3 times 0 minus, if y is times 0, I go minus 2 times 0. Okay, 3 times 0 is 0, take away 2 times 0, which is still 0. 0 is less than 8. Well, that statement is true. Okay, 0 is in fact less than 8. So because that's true, we shade the region that has the point in it. So here I'm going to shade this half of the line containing that 0, 0 point. Okay, if I'd picked a point out on the other side somewhere, let's say I picked this point here, 3, negative 1, okay? If I substitute that into this equation, I would have gotten a false answer and I still would have known to color in the other side. So it doesn't matter what point you select, just make sure it's not one on the line. Okay, and then again, we're going to label the line, the region, the required region. Okay, and that's it. That's how we plot regions defined by inequalities on the Cartesian plane. That concludes today's lesson, guys. As always, if you have any questions, let me know. But otherwise, good luck with the work, and I will speak to you all very soon.